Let's determine the constants C1, C2 using the general solution equation given here. That is y equals C1 e raised to the power of 4x times cos 4x plus C2 e raised to the power of 4x sin 4x. We'll also use these initial conditions to determine the constant C1 and C2. So let's see how to do this one. So since we have this general solution and we also have this initial condition, that is y prime of 0 equals 28, so we have to find the first derivative of this solution equation. So I'm going to find the derivative of the solution equation by differentiating both sides with respect to x. So when you differentiate y, we will get y prime, which is the derivative of y with respect to x. And we have to find the derivative of the right side expression. That is, we have to find the derivative of each terms one by one. So let me consider the first term. In this, the C1 is a constant. So using the constant multiple rule, I put this constant as it is. And then when we look at this product, we can consider this as a product. That is e raised to the power of 4x and cos 4x. This is a product. So we can consider the e raised to the power of 4x as the first term and cos 4x as the second term. So we can apply the product rule, and when we apply the product rule, we have to write the derivative of the first. I'm going to find the derivative of 4x, e raised to the power of 4x. This is e raised to the power of 4x times the derivative of 4x. By applying the chain rule, we find the derivative of 4x, and this is found to be 4. So basically the derivative of e raised to the power of 4x using the chain rule is 4e 4 power 4x. So I write down this as 4e power 4x. So this is the derivative of first times the second function. So I write down the second function as it is, plus now we put the first function as it is, that is e raised to the power of 4x times the derivative of cos of 4x. We can find the derivative of cos of 4x by applying the chain rule. So first find the derivative of cos 4x. This is negative sine 4x, and then multiply with the derivative of the 4x. When we apply the chain rule, we find the derivative of 4x, which is 4. So this is basically negative 4 sine 4x. So I'm going to put negative 4 sine 4x. So we are done with the derivative of the first term. Now we will do the derivative of the second term. We just clean this up. So in the second term, I consider this as a constant, and the e power 4x, I can consider this as a first term, and sine of 4x, I can consider this second term. So therefore, I put C2 times the derivative of the first, that is e power 4x, is 4e power 4x times the second, that is sine of 4x, plus we put the first as it is, that is e power 4x times the derivative of sine 4x. So the derivative of sine 4x will be cos 4x, and then when we apply the chain rule, we find the derivative of 4x, which is 4. So this is 4 cos 4x. Now let's simplify this by factoring out some like terms. So I can write down this y prime. Notice that we have 4 e power 4x here, as well as here also we have 4 times of e power 4x cos 4x. And this means we have a product multiplier C1 here, and we have a product multiplier C2 here. So when we factor the 4 e power 4x times cos x, I put this term, the factor term is 4 e power 4x times cos of 4x. When we factor this, in the first, that is in this term, we will have C1, and in this term, it's a product multiplier with C2, so it will be left with C2. And similarly, I can now factor this 4 e power 4x sine 4x, as well as this is also 4 e power 4x sine 4x, but we have a negative. So let's factor this. So I'll be left with 4 e power 4x sine of 4x. I'm factoring this term, and in this expression I have a multiplier c2, and here I have a multiplier c1 times negative, so it is negative c2. I'm sorry, negative c1. So this is what we obtained for y prime. Now let's use the initial conditions, that is y of 0 is 3 and y prime of 0 is 28. So I'm going to use this initial condition, y prime of 0 equals 28. That is when x equals 0, y equal, that is y prime equals 28. So let me substitute y prime equals 28 here and x equal to 0 in this right side expression. So I'm going to get 4e power 4 times of 0 times this is cos of 4 times of 0 multiplied with c1 plus c2 plus 4e raised to the power of 4 times of 0 and then sine 0 multiplied with c2 minus c1. Notice that 4 e power 4 0, this is 0, e power 0 is 1. So this reduces to 4 times of 1 and 4 times of 0 is 0. So cos 0 is 1, this reduces to 1 and we have c1 plus c2 plus since sine 0 is 0, this complete second term will get cancelled. So we will be just left with 4 times of 1 times of 1, which is 4 times of c1 plus c2, and on the left side we have 28. Now we can simplify and rewrite this as c1 plus c2 equals 28 divided by 4 is 7. Let's say this is equation 1. Now let's use the other initial condition, that is y0 equals 3. We have other initial condition, y of 0 equals 3, and for that I'm going to write the solution equation which is given in this question, that is y equals c1 e power 4x cos 4x plus c2 e raised to the power of 4x sine 4x. Okay, so let's substitute x equal to 0 and y equal to 3 into this solution equation. And when we do that, we get 3 equals c1 e raised to the power of 4 times of 0 cos of 4 times of 0. This is 4 times of 0 plus c2 e raised to the power of 4 times of 0 and sine of 4 times of 0. We know that sine of 4 times of 0 is 0. So this complete second term will get 0. And here we will be left with this is 3. E power 0, this is 1. So we will have c times of 1. And cos of 4 times of 0 is 0. So cos 0 is 1. So this reduces to 3 equal to c1. Otherwise, we can say that the value of c1 equals 3. So we have found the value of the constant c1 equals 3, which means we can plug it into this equation. That is, the first equation is c1 plus c2 equals 7. So let's plug c1 equal to 3. So we get c1, that is 3, plus c2 equals 7. And this gives c2 equals 7 minus 3, which is 4. So we determine the values of C1 and C2. That is C1 equals 3 and C2 equals 4. And so now we can plug these values, constants C1 and C2, into the general solution equation. That is, this is the general solution equation to obtain unique solution. So let's do that. We have the general solution equation, that is y1 equals c1 e raised to the power of 4x cos of 4x plus c2 e raised to the power of 4x and sine of 4x. And when we plug in c1 equal to 3, c1 equals 3 and c2 equals 4. So this is 3e power 4x cos of 4x plus c2 is 4, 4 times of e power 4x and then multiplied with sine of 4x. So this is basically the unique solution. In fact, we can rewrite this in a different form by factoring out e power 4x. And when we do that, we get y equals, I'm factoring out e power 4x. So I get 3 cos 4x and plus 4 sine 4x. So we could consider this as another form of the unique solution, or else we could also consider this another form of unique solution of the given differential equation.